Okay, so as we just talked about in our objective, we're focusing on just the quadratic regression today. So the stat over 5 enter is what we're focusing on, and we're going to look at some of the patterns that just quadratic shows. So our situation here is a 12-ounce can of soda was put into a freezer. The table shows the volume of the soda in the can measured at different temperatures. So our temperature is going to be our x, and our volume is our y. So if you can look at it, you can see at 68, it's 355, 50, 354. It stays really, really close to each other. But again, if you just look at the distribution, if it starts at 68 degrees and it's 355, at 14 it's also 355. So if you're looking at these numbers, they decrease and then they start increasing. So it decreases, and this is your answer for 1, then increases again. And we know that in quadratics, they increase and they decrease. So they go up and down, or they go down then up. So that's our answer for number 1. Number 2, we're going to create a scatter plot. This one's a little hard to do because these numbers are so close, but do the best that you can. So for 68, it's 355.51. So like right here. Okay. And then 50, it's 354.98. And then 354.89 for 42. So very close again. See how it's decreasing? 39, about right here. 35, 354.89. 32, 354.93, so we're getting a little bit above. 23, 355.13. And then 14, 355.54. Right there. So again, it sort of forms a U, a quadratic. All right, so that's for 1 and 2. This was on page 948. Now to go to the next page, 955. Well, it says choose a regression equation that best models, sketch the graph of the regression on the coordinate plane, explain why the regression model is best status. So we already know that quadratic is best, because that's what we're focusing on today. And we also know it based on the shape and based on the numbers that our table showed. So we need to find the y equals our equation, and we're also going to find the r squared while we're at it. So we're going to go to our calculator. Give me a second to pull mine up. We're going to clear what's in here. Second plus 4, enter. Stat, enter. And then we're going to start typing it in. 68.0. Oh, where did that go? I don't know why it looks like that. 50. 42.8. 39.2. 35.6. 32. 23. 14. And then I'm going to go to the L2. 355.51. 354.98. 354.89. 354.88. 354.89. 354.93. 355.13. 355.54. Okay, and then I'm going to see where my calculator is. I don't really know. Okay. So we'll do stat over, and we're going to do quadratic, which is number 5. Okay, so stat over 5. Sorry for the technical difficulties. And then here's the equation we get. Again, a lot of you are getting much better at writing these. Now here's the tricky part. This A. A lot of people always ask us what this E-4 means. It means we need to move this decimal place 4 places to the left. And I'm going to show you what that looks like. That's our A. It's just such a very tiny number. And then our B and then our C. So we're going to go back over here, and that's what we're going to write in. 0.00088 x squared minus 0.07x plus 356.38. And our r squared was 0.98. So that's our equation, and that's our r squared. Now, domain and range of the function. Remember how we do domain? Our smallest is less than or equal to x, which is less than or equal to our largest x value. Our range, our smallest y less than or equal to y, less than or equal to our largest y value. Our domain is going to be 14.0, so that's our smallest x, and our largest x was 68.0. This always confuses people because if you look back at the table, just because 68 is first doesn't mean it goes first in our domain. Our smallest number goes first, then our largest number. And then for our range, 354.88 was our smallest, and 355.54. Very similar, okay? Not much of a range here. All right, 5. It says use your regression equation to answer the following questions. Determine the y-intercept and interpret its meaning for this problem situation. Our y-intercept, people always forget this, is the c value. Okay, and our c value was 356.38 based on our equation. Again, that's looking at this part right here, 356.38. So what does it mean? It was our starting volume. That's how much was in the can at the start of this situation. We're going to skip number 6. Now number 7, we're going to let you do yourself. You need to substitute 20 degrees in for x and solve. You need to substitute 60 degrees into x and solve. In for the x for both equations, or for both x's. In for this x right here and this x right here. Okay, so that's what you need to do on your own. Something to remember about these is identify key characteristics and describe the meaning, because you can never have an answer of 0. Okay, nothing's ever going to diminish completely. So it can never equal 0. Something to always remember. Think about the situation in real life. Make sure you solve this 7. Okay, our second problem is a little trickier, but not too bad. Deals with donations for a local charity. So we have a donation amount, $2, $3, $4, and how many people agreed to give $2. So this is saying 400 people agreed to give $2. 360 people agreed to give $3, and so forth. So if you're looking at it, there's 3 different things that we can notice right away. Okay, the first thing is, if you look at these numbers, we're decreasing, decreasing. Okay? But these numbers are increasing. So x increases while y decreases. So since it's not doing both, we can assume that it's either linear or exponential. We're not sure which one, but remember, linear or exponential only decrease or only decrease. I don't know why that happened. So our numbers start high and end low. I'm struggling writing today, sorry. Okay, So those are just 3 things that we can notice right off the bat. It makes your life easier if you can take a look at this right away. Now, if we look at number 2. Number 2, it doesn't actually tell us how much money is collected in that table, so that's what we need to figure out. Now we're going to do 2 times 400, 3 times 360, and that'll tell us how much money is actually in our pocket to donate to this charity. So 2 times 400 is 800, and I'm going to try my best writing nicely here. Now 3 times 360 is 1080. Then we have 1280. 1400. Then we have 1440. Then we have 1400 again. Then we have 1280. Then we have 1080. 800. 440. And then 0. Now, here's where we're going to compare. Now, imagine that this is our x and this is our y. And what do we see? Well, we see that this is increasing and then decreasing. And so for part 2, we know if something's increasing and decreasing, we know it's quadratic. Now, do we see any repeats? Yes. So some are repeats. You notice we have 800 up here, 800, 1080, 1080, 1280, 1280, and so forth. Okay. I'm going to skip or I'm going to make you do the graph for this one, sorry. Forgot we're skipping another problem. So the first one was 2, 800. So we're counting by 3s is 1.5, so 2 is about here. 800 would be about here, okay? I want you to finish this graph by yourself. Again, you have the table right in front of you there. 3, 1080. So 3 all the way up to 1080, which would be about here. And then see if you can see the pattern. You should see the pattern that starts to form. Again, you should get a quadratic. It should increase and then decrease. So I'll be looking for that graph. So if you flip over, now we're on page 952. Use a regression equation that best fits it. Well, we are going to use quadratic. I'm going to skip the calculator this time because I feel like we know how to do it. Number 5, we're going to do negative 40x squared plus 480x plus 0. And what was our r squared we got? It was 1. So it's perfect. Okay, number 6. Determine the y-intercept and interpret the meaning. Well, again, remember, our y-intercept is our c value, which equals 0 for this one. So think about it. When 0 people give $0, the charity makes $0. Kind of doesn't work with zeros, but think about it. It makes sense. If nobody donates, the charity gets nothing. Okay? We are going to do our x-intercepts for this one. This is when, remember, our x-intercepts is when y equals 0. It happened twice. It happens at 0, 0, and it happens at 12, 0. We look back at our table. See how it was 12, 0, and it gave us $0? That means that donation amounts at 0 and 12 made $0. Nobody gave $12. The highest they gave was what, 11? 11. All right, number 8, and this is one you're going to do yourself. Predict the total amount of money collected in each donation for the given amount. So this is $1. Substitute that in for X. And for Y, substitute that in for Y. I'm sorry. And for B, substitute 15 in for X. So substitute 15 in for X and 1 in for X and get some answers. Use that equation that we solved in number 5. All right, then you're going to skip number 9. And the only key characteristic I want to point out for you is the highest value. What our high point was. It was 6, 14, 40. And if you think about what that means, if you remember what a high point is, it's our vertex. So fun fact there. You're going to skip number 11. And then you're going to come to this one. And here's how you won't need to set it up. This is your X, your day number, and this is your total distance on your bike trip. Okay? We have our day number and our bike trip. What you need to do is what we've been practicing a bunch. You need to find your linear equation, your exponential, your quadratic, and your r squared. And then you need to decide which one's best. Okay. You need to create a scatter plot, and I'm actually going to cancel the scatter plot so you can cross off number 2. Number 3, tell me which one's best. Okay? Just tell me which one's best. So which one is best? 4. So now I want you to just substitute in when x equals 10 into your equation and see if it's different than the one you got from your table. And explain, does your equation always work, or sometimes does it not make sense in real world things? That is what you're going to be left with, and that is all. Okay, so try and finish those, and then let us know when you're done so that we can take a look at how you did.